In this video, we're going to look at the concept of the complex number, or what's also known as the imaginary number, I. So first, let's define I. I is equal to the square root of -1. This is significant because we can't take the square root of a negative number. It doesn't exist on a real number line. However, many times when we're solving equations, we may get a solution x is equal to plus or minus the square root of some negative number. And in that case, we don't want to write it as the square root of a negative number, so we introduce complex numbers, or what's known as I, to write our solution. So for instance, say we have an equation x is equal to plus or minus the square root of -16. We can take that and rewrite it as being plus or minus the square root of 16 times -1. And all we're really doing is we're saying -16 is the same as 16 times -1. But from there we can split it into two radicals, because a property of square roots is that we can split it into two separate radicals when we have something multiplied under it. So we get the square root of 16 multiplied by the square root of -1. So why do we do this? Because we defined I as being the square root of -1. So we can rewrite that square root of -1 simply being I. And we can simplify this square root as well. So we get our final answer as x being equal to plus or minus the square root of 16, which is 4, times I. The square root of -16 and 4i are the exact same thing, but we always want to record our answer in this form to show that it's a complex number and to be simpler than having the square root of -16. So to drive the point home, let's do one more example. If we get our solution x is equal to plus or minus the square root of -17, we can once again go through the same process with this, and that would be plus or minus the square root of 17 times -1, which we can again split into two radicals as we did in the previous problem, and we get the square root of 17 times the square root of -1. I did this example just to show that we're not always going to get perfect squares as we did with 16 simplifying down to 4. Here we can't simplify the square root of 17, but we'll record our final answer as x is equal to plus or minus the square root of 17 times I, as opposed to having a -17 under our radical. So whenever you're solving an equation, you should always seek to get rid of any negatives under the radical by rewriting it as being whatever it is multiplied by I.